Hello and welcome to this video. In this video we'll have an introduction to permutations. Let's take a look at example 1. List all possible permutations. We're given 4, 5, 6, and 7 and we're going to take 2 at a time. Recall that permutations are just ordering of those numbers. But since we're taking 2 at a time, I'm going to start off with 4. So I'm going to say I have 4, 5, or I could also have 4, 6, or 4, 7. In addition, I can say I can have 5, 4, 5, 6, and 5, 7. Moreover, I can also have 6, 4, 6, 5, and 6, 7. Lastly, I can have 7, 4, 7, 5, and 7, 6. So all the possible permutations from 4, 5, 6, 7 taken 2 at a time are listed below. We have a total of 12 of them, and here they are. Now let's take a look at another example. Example 2. Evaluate a permutation of 8 objects taken 3 at a time. In order for us to evaluate this expression, it's important that we recall the formula. If you have a permutation of n objects taken r at a time, we use the formula n factorial divided by n minus r factorial. In this case, notice your n is equal to 8 and your r is equal to 3. So 8p3, okay, the permutation of 8 objects taken 3 at a time is equal to 8 factorial divided by 8 minus 3 factorial. Now, this really means 8 factorial divided by 8 minus 3 is 5, so that's 5, and then the factorial here. Recall, though, that this means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all divided by 5 times 4 times 3 times 2 times 1. Now, take a look at this one. This is really 1, so I can cross it out. This is also 1. So is this, and this. So really, at the end of the day, we have that the permutation, or the number of permutations of 8 objects taken 3 at a time is equal to 8 times 7 times 6, which happens to be 336. Okay? Let's see one last example here. Example 3. Find the number of unique permutations of the word thinking. First of all, I'm interested in the number of letters involved in the word. I have 1, 2, 3, 4, 5, 6, 7, 8. So n is equal to 8. In addition, what I'm going to do, I'm going to list the different letters. So I know I have T's, I have H's, I have I's, I have N, I have K, I also have N, but I already included it here, and then I have G. Let's list the frequencies here. By frequencies, I mean the number of times that they're actually showing up in the word. Now notice the T, we only have 1 here. In terms of the H's, we also have 1. We have 2 I's in the word thinking. We also have 2 N's. We have K, which is 1. And we have G, which is also 1. Now, the formula for us to find the unique permutations is as follows. We actually take n factorial divided by, in this case, since I have 6 different letters, it will be s sub 1 factorial times s of 2 factorial times s of 3 factorial times s of 4 factorial, s of 5 factorial, and s of 6 factorial. Now, what are these s's of 1, s of 2, s of 3, s of 4, s of 5, and s of 6? Those are the frequencies here. So notice, I'm going to replace, I know my n is 8, so I have 8 factorial, over the frequency of t is 1, so I have 1 factorial. The frequency of h is also 1, I have 1 factorial. The frequency of I is 2, so that's 2 factorial. The frequency of n is 2, so that's 2 factorial. The frequency of k is 1, so that's 1 factorial. The frequency of g is 1, that's 1 factorial. Now, keeping in mind and remembering that 0 factorial is equal to 1 and 1 factorial is equal to 1 as well, we realize that these are a bunch of 1s here. So those are 1s, so are this, and so is this. So that leaves us with 8 factorial divided by 2 factorial. Now, let me write it here. 2 factorial means 2 times 1, so that's just 2. So I have 2 factorial times 2 factorial. Since I already said that 2 factorial is 2, this is 8 factorial over 2 times 2. So that's 8 factorial over 4. And 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all divided by 4. Here, I'm going to cancel out the 4's, and I'm going to just multiply 8 times 7 times 6 times 5 times 3 times 2 times 1. And by doing that, I'm going to get that this happens to be 10,080. So it's 10,080. Okay, and since I cannot, I ran out of room here, let me write it underneath it. So this is going to be 10,080, which implies that we have 10,080 unique permutations of the word thinking. So let me write it here for you. We have 10,080 unique permutations of the word thinking. Okay, so keep in mind, this was our formula: n factorial over the frequency of the first letter factorial, frequency of the second letter factorial, frequency of the third letter factorial, and so forth. Okay, that concludes our video in terms of the introduction to permutations. I hope you enjoyed. Good luck in your homework.